Hello. So if you're new to the channel, welcome. And if you are a returning viewer, welcome back. Today, we're going to be discussing building chatbot applications on top of open source large language models. I think going forward, open source large language models are going to be absolutely huge. We've just recently heard from Mark Zuckerberg that Meta are going to invest heavily in their GPUs for training their own open source large language models. Specifically, we know they're going to invest in 350,000 H100s. No doubt this is going to be used to train their next most performant open source model, which will probably be Llama 3. With this rise in interest in open source LLMs, I believe that a lot of engineers are going to want to divert their attention to learning how to develop applications on top of open source large language models. So in this video, I'm going to be revealing 5 tips for building your chatbot on top of a large language model that is open source. If you're used to using the OpenAI API, there are a lot of things that are already done for you behind the scenes, and you won't have had to run into those engineering tricks that you will have to know if you're going to develop open source. So if that's you, please continue to watch. I'm sure this video is going to be very helpful for you. If you like this content, please remember to like the video, share, comment, and subscribe to the channel for more AI and large language model focused content. All right, so let's get into the technical details. Okay, so let's get into tip number 1. So tip number 1 is to assess your hardware and know your budget. Now, that might sound obvious to those that have worked with open source large language models before, but for those of you that haven't worked with open source large language models, what you've got to understand is these things are very resource intensive. So yes, you might have heard out there that there's this new 180 billion parameter model that is outperforming GPT 3.5, or there's Mistral out there that is doing wonders. But at the end of the day, you need to know your hardware requirements and you need to know your budget, because if you don't have the hardware to host a Mistral or a Falcon 180B, there's no sense in looking at that as an option. And with thousands of large language models available to you, open source on Hugging Face, you will need to have that understanding that not all of those will actually be suitable for your use case. So tip number 1 is to assess your hardware and understand your budget. So let's take what we're using for our chatbot in this video as an example. So we'll be using Mistral, and I'm on a budget here. I'm on a strict budget. So my hardware is going to be something I'm renting from Rumpod, which is going to be the RTX 4000 ADA, right? That's going to be costing me 39 cents per hour. So it's relatively cheap, but that's the hardware I'm working with. All right. So how do I assess whether I can actually work with Mistral? It turns out it's quite easy, right? Because let's step into Hugging Face. Let's take Mistral as our case study for an open source LLM, and let's see how we'd assess whether our hardware is good enough to host a Mistral. So what we can do is we can navigate to the Hugging Face page, which is what you should be seeing on screen now. And what you want to do is grab the path. Once you've grabbed that path, you can navigate to this Hugging Face space. It's called Can You Run It? So I'll link to this in the description to this video. And you simply just want to paste that in here, right? And then hit enter. And what that's going to do is this is a Streamlit application that tells you whether or not your model that you want to host is suitable to run on your hardware. So we've set our GPU vendor to NVIDIA. Let's also grab the GPU we're working with. So I believe it was the RTX 4000 ADA. Let's just have a look. It should actually be listed here. Let's just have a look. Let me head back to Rumpod and just see. Try to remember that was RTX 4000 ADA. That's correct. ADA. Right, there we go. So let's grab that. And what's amazing about this is it will tell us, yes, you can actually use this GPU to run inference on Mistral, which is great because it's really cheap. So, you only require 1 GPU. It says also you only require 1 GPU for full training, and you only require 1 GPU for LoRa fine-tuning. So I'm not sure that that's correct for full training, The other thing you want to do here is expand this table because it only comes out with a little bit of it. But yes, so for full training, it's actually saying you need 109 gig. And this GPU is actually much less than that. So I'm not sure it's correct on the full training part, but for sure, we can run inference. And especially if we're loading it in float 16. So loading in float 16 just means we're loading the model in lower precision. By default, there are a lot of models that are at float 32, so that's full precision, but we can load it in half precision without too much impact on the performance of the model itself. So if we load it in float 16, we've taken only half of the required gigabytes for inference, which is really good if we're trying to work with limited hardware. So that's how you can assess whether your hardware is good enough. You go to that, can you run it? And can you run it is brilliant because it works, again, with your hardware. So let's see if we wanted to run a larger model. Let's see what it would do. So if we step back, let's look at something like Falcon 180B. And it's obvious already that we're not going to be able to run this, but just as an example for you. And we step back into, can you run it? Let's paste Falcon in there and let us also go ahead with our, are we blocked? It's a gated model. I need to provide my access token. So let's use one that I don't need to provide my access token to. What about, let's go with the News Hermes Yi 34 billion, right? So let's do that one. Right, and we'll paste that in. Great, and we'll go back to the GPU we have, which is the RTX 4000 Ada. And as you can see, it says we can actually perform inference on the model, but we can't do any GPU training and we can't do any LoRa fine-tuning. We'd need 2 GPUs to do that, and we'd need 4 to do training. So this is a really valuable resource for you if you are looking to work with open source models. First, understand the hardware that you've got, understand what you're working with. A lot of you won't have the required CUDA capable GPUs on your computer. And if you do have them, they're probably not going to be large enough. And that means you might have to go on a service like RunPod to actually rent a GPU like I'm doing. So that's the first thing, understand the requirements and understand your budget. So even when you're on RunPod, you might not have the budget to be renting the state-of-the-art GPUs at like $4 or $8 per hour. You might only be able to afford to rent a smaller GPU. So once you know those 2 things, you can come onto, can you run it? And you can assess for the model that you've chosen what you can assess whether the model that you want to work with is actually suitable for your hardware setup. So that's it for tip 1. Understand your budget and understand your hardware. Okay, so let's move on to tip number 2. And tip number 2 is to understand the difference between your instruct models or your chat models and your, what I like to call the baseline or the raw models. All right, so on screen now, we're at Hugging Face and we're using our Mistral example again. And as you can see, there are different versions of Mistral here. So ignoring the 2 Mistral models at the top, although it applies to those as well. If you look, you've got Mistral 7B Instruct, and then you've got Mistral 7B here. And you'll find this theme in common with a lot of the foundation models that have been released. There's just what I like to call a baseline version, and there is an instruct version. But what's actually the difference between these 2? So this is a really important distinction, especially if you're going to be using these models to build a chatbot. In short, you cannot build a chatbot on top of the baseline models. Here's why. The baseline models are just literally pre-trained on large volumes of text to predict the next word. So the outputs are really messy when they're doing text generation. And I'm going to demonstrate that in a minute. The instruct versions, however, have been fine-tuned to be able to follow instructions. So that includes things like responding to queries or answering questions, which makes them a lot more suitable for chatbot applications. So we can demo this because I already have both the instruct model and the baseline model deployed on RunPod, and I've built them into a LangChain chatbot application, and I'm going to show you what both look like. So let me bring up my VS Code. So you can see here, we're going to, let's start off with the instruct model first. And here is my endpoint deployed on LangChain. So I'm not going to go into the details of the code. This is to demonstrate to you the difference. So let me pull up the Chainlit application, which is the front end for this model. So Chainlit run chat LangChain.py. And just a tip for you that if you've worked with Chainlit before, the front end for your chatbots, if you put this W here, if you put that parameter, you don't need to keep restarting it. It will just update in the background if you make changes to your script. So let's run that and let's enter our Chainlit front end. So that's pulling up on another screen. I'll bring that in as soon as it's ready. Great. So we have our Mistral instruct deployed in our Chainlit application. So if I say something like, and just to give you a bit of context, there's a prompt behind this. Before I get into the model, just there is a prompt behind this that is asking the model to behave like a fitness personal trainer. So if it starts giving fitness responses, it's because I've prompted it to do that, just to make you aware. So if I say something like, "Hi, how are you?" So that's running. "Hey, I'm great, and I'm here to help you answer any fitness-related questions you might have. How can I assist you today?" So that is as expected because we're using the instruct version of the model. Now, what happens when we don't use the instruct version of the model? So that's easily done. Let me step back into my code. And I'm going to comment out the instruct version. And instead, we will use the raw version or the foundation version. We'll hit save, and that's going to update the Chainlit front end. Find that thing. So just wait a few seconds for that to update. So that is updated now. So you can see we are using just the standard or the foundation or raw version. So, "Hi, how are you?" Let's test it out. And we just get an H, which is not what we're looking for. And I wonder why that is. It's because we're not using the right version of the model. So let's test it again. "Can you give me some fitness advice?" And H again. And that's what happens when you do not use the right version of the model. You get unexpected results. Just to make you comfortable with this, let me remove the stopping token and see if that makes any difference here. So I've removed the stopping token. So all that does is it tells the model when to stop generating text, and that's why it's stopping at that H. Let's just see what happens. Let's see if we can trick the model into giving us a response, even though we're not using the chat version. "Hi, how are you?" So you can see we're still using the foundation version. And there we go. So you get very unexpected results. This is not what we're looking for, and it's not suitable for chat applications. And the reason for this is because at its heart, it's just a next word predictor. So we've given it this prompt, and I'll go into a bit of the details about the prompt in the next section. But we've given it this prompt, and all it's doing is it's predicting the next word from that prompt. And it's generating a whole conversation here, which is just completely useless for a chat application. So that is it for the second tip. The second tip is you need to choose the right version of the model. So if you're building chat applications, you need to use the instruct version of the model. Otherwise, you need to fine-tune the foundation version of the model to follow instructions. And that's how you're going to get reliable responses for your chat applications. So don't fall into the trap of getting excited about a new foundation model coming out and saying, "Hey, I'm going to throw this into my chatbot application." It's not going to work unless you have fine-tuned it to follow instructions. Great. We'll move on to the next tip. Okay, so now for tip 3. And tip 3 is to watch out for commercial use restrictions. So it can be tempting to get really excited about all of the foundation models released on Hugging Face. There are literally thousands available to you. But what you should be aware of is that not all of those are actually suitable, or not all of those you are allowed to use for commercial purposes. So a great example of this is something like Orca from Microsoft. So let's have a look at Orca 2, which is a great model. It has been trained specifically to be able to follow complex instructions and do complex reasoning tasks, which is fantastic, and a great way in the direction of having some open source models that are able to be used for agent workflows. However, if you look at the license here, this is a Microsoft research license. So you can see all the licenses. Usually with models that you can get on Hugging Face, the licenses are going to be attached to the model card. So yeah, this is a research license, and I think they even go into a bit more detail about the license itself. So Orca 2 is licensed under the Microsoft research license, and there's a Llama 2 thing here as well. Maybe the model's based on Llama 2, but let's have a look at the Microsoft research license. So if there's a lot of information here. I'm just going to do a control find, see if I can see anything about commercial, but I'm almost certain that you cannot use. Here we go. Yeah. There we go. So subject to the terms of this agreement, you have the below rights, if applicable, to use materials solely for non-commercial, non-revenue generating research purposes. So there you go. So you cannot use every single model on here for commercial purposes. On the other hand, if we look at something like Mistral, that is going to be under an Apache 2 license, I believe, which means that you can actually use the model for commercial purposes. So let's just have a look and make sure. We'll go to the instruct version, and you can see there's the Apache 2 license. Let's just have a look. Mm-hmm. Yeah, there we go. So it's under the permission. So commercial use, distribution, modification, pattern use, private use. So that's what you want if you are trying to build an application for a client that you have, or maybe you're trying to build an application for your own business. You want to make sure that you're using the right models that are actually licensed for commercial use. So you want to be looking out for things like the research licenses, and you want to see something like Apache 2. There you go. So that is tip number 3. Make sure that the model you're using is actually licensed for commercial use. It's really easy to overlook this point, but will save you a lot of money down the line and save you a lot of problems and headache. Okay, so let's move on to our penultimate tip, tip number 4. And tip 4 is to make sure that you do not ignore the prompt templates. And this is really important. Some models don't require a prompt template, but in general, a lot of the models that you're going to run into do require a prompt template, or, you know, you might also hear about them being called prompt formats, but either way, you cannot ignore the prompt formatting, the prompt template. Now, let's use Mistral as an example, the Mistral instruct model, and I'll get into what the prompt format looks like for Mistral and why it's important. So navigating to the Mistral Hugging Face page, you can look at the model card, and what you can see here is there is an actual format that you need to follow if you want to use this model for text generation. And you can see it's quite a simple one. There are more complex ones. So if you look at Llama 2, for example, Llama 2 has a prompt format that is a bit more complex than this. But what it's saying to you is that you need to, so in order to leverage the instruction fine-tuning aspect of the model, you need to your prompt must be surrounded by these tokens. Right, and then they've given us an example here. So you can see the query is surrounded by this beginning of sentence token, and then there is an end of sentence token here as well. So you need to make sure that if you are going to use this model, that you follow this prompt style or this prompt template that is in this model card. So let's have a look at what happens if we ignore the prompt template. So the first thing I want to show you is how I'm using the prompt template in the code. So I've already demonstrated the Mistral instruct, which is working with the prompt template they've suggested. And with LangChain, they give you the option here to put that prompt template in. So you can see those tokens that's wrapping around every bit of text that I need the model to be able to interpret. All right. So that is with the prompt template, and I've shown that that works well. Now let's do this. Let's comment out this prompt template. And, you know, LangChain does provide you with the, like I said, LangChain provides you with the ability to customize those prompt templates. And let's use one that violates what they've asked for. So I've essentially just removed those tokens from the prompt template, and I'll hit save on that. And then I'm going to bring up the Chainlit front end for us to test. If I can actually find where I've put that thing. Ah, here we go. Great. So we're still running on the instruct version of Mistral. And I'm going to say, hi, how are you? And there we go. So we have actually broken the model by removing the prompt template as it was suggested by the model card. And you can see this when you read this. This is kind of like, it doesn't even make sense. It's not a response to what we said. We said, hi, how are you? And it says, I'm new to working out, and I've heard a lot about HIIT workouts. What exactly are they, and how often should I do them? So it's just talking to itself, basically. So do not ignore the prompt templates or the prompt formats. You should ensure that when you go on model, when you go on Hugging Face and you look at the model card, you pay attention to the prompt template or prompt format they've suggested, and make sure that you incorporate that into your application. If you're using things like LangChain, they usually provide a way to customize your prompt formats or your prompt templates so that it matches what is suggested. You need to be careful with services like that as well, because they have a lot of hidden prompts behind the scenes, and they're designed to work with OpenAI a lot of the time. So if you're using an open source model, you will need to create custom prompt templates, and you'll need to make sure that you're bypassing those hidden prompts that are hidden deep in the repositories of frameworks like LangChain or frameworks like Haystack or Llama Index. You won't get, that's probably why, you know, for a lot of people, when they use open source models to substitute into the applications, they don't work well because they're not using the prompt templates. They're not paying attention to that. And that is it for tip 4. Pay attention to the prompt templates. Another thing is, if you are using a model and you notice that the prompt template is missing, or there's no prompt format mentioned, or the model card is just not updated well, I suggest that you use a different model. All right. Pay attention to the prompt template. Great. So now it's time for our final tip. And this is really important if you're building chat-like applications. And this is that you need to incorporate a memory into your chat application. It's taken for granted when you use things like ChatGPT that large language models can just understand previous context in the conversation. This isn't the case when you're using open source models. There is nothing inherent in an open source model that means that it can remember the last things that have been said in a conversation. You have to incorporate that memory in. And to do this, we use engineering tricks like feeding the context back into the prompt itself. So I'll show you where I've done that. So if you have a look at this prompt format, what I have here is a history. So that history is essentially the history of the conversation, and I feed that back into the prompt. So whenever I'm querying that large language model through the chat interface, it has a record of everything that has come before it so that the conversation flows naturally. So if you don't include a memory, the conversation will be very unnatural, it will be disjointed, and it will sound like you're talking to an idiot. Okay, so always include a memory, include a history. Frameworks like LangChain allow you to easily do this, and I'll show you an example now. So let's have a look at what the model looks like with the memory included. I've got a list of 3 questions that test memory. Right. I'm going to start off. Remember, this is a strength and conditioning coach, or a fitness coach called Fitness Dave. So that's the first question. Hi, Fitness Dave. So just in case you didn't see that, that went quite quickly. So the question was, let's scroll up. The question was, hey, Fitness Dave, I'm looking to improve my upper body strength. Can you suggest a couple of exercises to start off with? Absolutely, I'd be happy to help. For building upper body strength, you might want to consider incorporating exercises like push-ups, pull-ups, and dips into your routine. These exercises work well, work multiple muscle groups in your upper body, including your chest, back, and shoulders. Remember to start with sets of 10 to 12 reps for 2 to 3 per exercise to build a foundation. As you progress, you can increase the number of sets or reps. So that sounds like sensible advice. Now let's continue the conversation. So we'll say something like, thanks for those suggestions. How often should I do these exercises to see progress? Hopefully there'll be some consistency here. Ideally, you should aim for at least 2 full body workouts per week to see noticeable progress in your upper body strength. Incorporate these exercises on those days, allowing for at least 1 rest day in between to allow your muscles to recover. Remember, consistency is key. Okay. So that aligns. It still remembers that we're talking about upper body, and it remembers it's you know, it's coherent. It's a coherent response, and we wouldn't question anything about that if we were using this chatbot. So the last one is, also last time I tried similar exercises, I had some shoulder pain. Any tips on how to avoid that? So it would have to understand the exercises that's recommended to us already, which is a test of memory. So let's see how it does with that. Absolutely, I understand your concern. So absolutely, I understand your concern. Proper form is crucial to prevent injuries. When doing push-ups, so it's recognized that suggested push-ups, keep your body in a straight line from head to heels and engage your core to maintain a neutral sign. For pull-ups, recognize it's recommended that. Make sure you pull your shoulder blades down and back before initiating the movement. For dips, your elbows should be 45 degrees angle to your body. If you're still experiencing pain, consider starting with assisted version of these exercises or consulting a healthcare professional. So that's coherent, and clearly the memory component is feeding in. I just want to show you how this memory component is working before I show you what this conversation looks like when you don't include a memory. So step back into the code. I have a little bit of code here that shows you the memory component and how that kind of builds up. So I'm going to uncomment that. All right, I'm just going to put a note here to remind me to comment. Oh, we don't want that in there. Just put a note here. Shows memory. Just reminds me to comment that out. I'm going to hit save on that and refresh the front end. That front end should be refreshed. I'm going to put those questions across again, and you'll see how the memory is being fed back into the conversation. So we start off like that. Right. So this is the debug info. This is the memory. So here you can see the content of the memory. Hey, Fitness Dave. And there's our question, and there's the response from the AI. And you're going to see this thing is going to grow as we send more messages. So it keeps track of the conversation. So here's the response again. And there's the debug message. So you can see the debug message is growing. So there was the first one, hey, Fitness Dave. And the second one was, thanks for those suggestions. And you can see the response from Fitness Dave. So I won't go on to do the third one, but you get the point. It is concatenating the conversation and feeding it back into the prompt. All right. And that's how you get a consistent conversation. Now, obviously, the context of your model matters. This memory component can only be as large as the context allows for your model. So as the memory grows, you're going to have some problems with context. So you need to put in a mechanism that once the memory reaches a certain point, it cuts off, or there's a sliding window type of memory so that it never outgrows the context. That's something you need to consider as well. Right. So let us step back into the code. I'm going to remove that memory debug, and then I'm going to remove the memory from the chatbot. So by commenting out this memory .save context, now the chatbot has no memory. And let's see what that plays out like. So that has saved, and in the background, we should be refreshing our fitness chatbot. Now that that's refreshed and we're still running the Mistral instruct, let's start off. So great, all good so far. Seems sensible. Chest, triceps, and shoulders, dumbbell rows, back and biceps. So we've got a different set of exercises, but fine. It seems sensible enough. Let's see. So let's go. Thanks for those suggestions. Aha. So thanks for those suggestions. How often should I do these exercises to see progress? So it can kind of blag this one. Generally, I'd recommend performing each workout 2 to 3 times, giving your muscles adequate time to recover in between sessions. However, frequency can depend on factors like your current fitness levels and goals. Okay, so that is a bit of a blag. It's not specific at all. Let's move on to the final question, and it would need to know the exercises to really answer this question specifically. Absolutely. Here we go. So we've been given a long answer, but actually this is not consistent with the conversation. And you can see that because it just says absolutely human. Shoulder pain during workouts is common, especially with exercises that target the shoulders or involve overhead motions. Here are a few tips to prevent or minimize the pain. Warm up properly. I'm not going to read all of that, but you get the point. Use correct form and technique. Use lighter weights. Give your shoulders adequate rest. Consider incorporating exercises to strengthen the muscles surrounding the shoulder. So the point here is that it's not specific at all because it has no recollection of the exercises it recommended us because there's no memory component. So hopefully that demonstrates to you why the memory component is important if you are building chatbots based on open source large language models. It doesn't come in by default. You've got to program that memory in. Frameworks like Haystack, Llama Index, LangChain do come with modules to help you encode memory into your chatbot applications. You'll have to have a look at the documentation for that, but it is really important if you're to build a coherent chatbot application. That's it for tip 5. Okay, so we've come to the end of the video, and I hope that was useful for you. Just the recap of the 5 tips. Tip 1 is to assess your budget and hardware requirements and see if the large language model of choice, the open source model of choice, is suited to the constraints of that budget and hardware available to you. Tip 2 is to make sure you're using the right model. So you want to be using the instruct model if you're going to be building chat applications. If you use the raw model or the baseline model, I should say, it's not going to give you coherent responses. So you want to be using the instruct model, or you want to fine tune the baseline model to make sure that it's okay for following instructions so it can be used within a chatbot. Tip 3 was all about licenses. So we want to make sure that the models we use are available for commercial use. So the license means that it's appropriate for us to use commercially. You want to avoid research licenses, and you want to look out for things like Apache 2. Apache 2 generally means that you can use it for commercial purposes. Tip 4 was all about prompt templates. We want to make sure that we are adhering to the prompt templates, especially if we're using instruct models. If you break those prompt templates, again, you're going to get responses that are not coherent and don't make any sense. So always align with the prompt templates. Watch out when you're using applications like LangChain, or when you're using things like Haystack or Llama Index. There are hidden prompts that work behind the scenes, and they're designed often to work with OpenAI. We're using LLMs from Hugging Face. If you're using open source LLMs, then you're going to have to customize those prompt templates to align with what the model cards suggest on Hugging Face. And last but not least, tip 5 was all about memory. So let's just make sure that when you're building chat applications that you incorporate a memory component so that the conversations are coherent and actually consistent across messages. Without incorporating a memory component, what happens is it just kind of sounds like you're talking to an idiot. The chatbot doesn't inherently remember what was said in the last conversation. There's nothing about large language models or the transformer architecture underneath it that means that it can carry messages on without you engineering them into the context. The other thing to be aware of when it comes to memory as well is that the context window of your model. So if your context window is 8,000 tokens, your memory will grow and grow and grow and eventually exceed that context window. So you want to make sure there's a mechanism in place to handle that. So whether you do that with a sliding window memory where it captures a certain amount of tokens and then after slides across and forgets another part and captures the new part, or whether you do that with just like a straight cutoff of memory at a certain point. That's up to you. That's a design decision, but make sure that you're aware that your memory can outgrow your context. That's it. If you enjoyed this content, please like the video. If you have any tips on building chatbot applications on top of open source large language models, please throw them in the comments. Any other suggestions, throw them in the comments. If you like this content, please subscribe to the channel for more content on large language models, artificial intelligence. Thank you for tuning in again, and I look forward to seeing you on the next video.